All right, so we're going to try to do the review of number chapter 5 here. And so the first question says use 3 significant figures, but it also says a box contains 15 chocolates, 12 nut, and 10 caramels. So the one thing we're going to need if this is a probability question is to add those up. So I would just do my 10 plus 12 plus 15, and I get a total of 37. All righty. And then the actual question is, if one candy is randomly selected, what is the probability the chosen candy is a nut candy? So for part A, we would do the probability of it being a nut candy would be the 12 that are nut all over the 37 total. And then we can approximate that to 3 significant figures. So take my 12, divide it by 37, and I'm going to get 0.2324. And that would be part A. And then part B says if one candy is randomly chosen, what is the probability the chosen candy is not a nut? So probability not a nut would be 1 minus the 12 out of 37, or you could say it's roughly 1 minus a 0.324. Use the complement because we already know what it is to be a nut. So 1 minus 0.324. And we're going to get 0.676, roughly. Okay. And then, oh, let me scroll down like that. If 2 candies are chosen with replacements, so you're going to take one out and put it back. What is the probability they are both caramels? So the probability it's a caramel, and then the probability it's caramel. These would be independent. It's sort of implied because if you put it back, so that would be 10 out of 37 for the first caramel, but then you're going to put it back. So 10 out of 37 for the second caramel, or you could say 10 out of 37 squared. And that would be roughly, take 10, divide it by 37, and square that, and you would get 0.073. Okay. And then the last one, we didn't do any of these last ones, but I'll go over this one anyway. If 2 candies are chosen without replacement, what is the probability they are both caramels? So the probability of a caramel, the probability of a caramel. The only difference in this one is there's 10 out of 37 ways to get the first one, but then since you took it out and you didn't put it back, there'd be 9 out of 36 ways to get the second. So you have to recognize the fact that you took something out of it. So I would do 10 divided by 37, and then parenthesis 9 divided by 36. And I would get 0.060675, so roughly 0.068. Okay, and that would be that answer. Okay, and then I didn't mean to scroll down there. That would be part A, or sorry, part D. And then number 2 would be a recent poll asked residents of a certain city, do you support hiring more teachers so class sizes can be lowered in the middle school? The table below gives the response information and identified political party of the respondents. Okay, I think this one's from the book. So for part A, if a person is randomly chosen, what is the probability they said yes? So the probability of a yes vote, and the only thing that we're going to have to do on this one is figure out the total. So what I might do to save ourselves a little bit of time, let's go over here and let's do the totals. 137 plus 80 plus 75 plus 15. That gives us a 307 total for the first column. And let's do the second column, 35 plus 105 plus 30 plus 10. That'll give us 180 for the second column. And then we'll do 28 plus 15 plus 5 plus 5. That'll give us the third column, which is 53. And then I'll do the rows as well. Let's do the first row. 137 plus 35 plus 28. That gives us 200 for the first row. Then we'll do 80 plus 105 plus 15 for the second row. That'll give us another 200. And then the last row would be 15 plus, oh, I'm skipping a row. I apologize for that. The third row would be 75 plus 30 plus 5. So that, oh, got that wrong. 75 plus 30 plus 5 would be 110. And then the last row would be a 15 plus 10 plus 5. So we get a 30. And then if we add up either the rows or the columns, we should get the same total. So 200 plus 200 plus 110 plus 30 gives us a grand total of 540. And we should get the same for the other. If we do 307 plus 180 plus 53, yeah, we get 540. Okay, so that's our total. So we will use that. So the probability of saying yes would be roughly, what would be 307 over 540. Can actually say equal for that. And then if we do the decimal approximation, we can say that that is roughly 307 divided by 540. And I get 0.5685, so roughly 0.569. Okay, so that would be A. B would be if one person is randomly chosen, what is the probability they are independent? So the probability of independent would be the independent row, there's 110 people out of the 540. So that would be roughly, I have no idea. So it would be 110 divided by 540, and I forgot a 0 there, so I'm going to add that 0. There we go. I get 0.2037, so 0.204 would be the rough guesstimate. And let's see, for part C, it would be if one person is randomly chosen, what is the probability they are Republican and said no? So the probability the Republican and said no. So we have to go where that row and column intersect, and it looks like there's 105 people there because they have to have both conditions. So it'd be 105 divided by the 540. And I get 0.19444, so just 0.194 would be the rough estimate. That would be C. And then D would be, is it unusual for a respondent to be a Republican who said yes? Why or why not? So the Republican and said yes. So if we look at that row, that would be 80 over the 540. So what we could do is take the 80, divide it by 540, and get 0.148. And the answer would be no. It is not unusual. Yeah. So for part D, we'd say since the probability of being Republican and saying yes is 0.148, which is greater than 0.05 or 5%, this event would not be unusual. Okay, and that would be our answer for that one. Is it unusual for a respondent? So that would be part D. So part E would be, is it unusual for a respondent to be an independent who said not sure, why or why not? So for part E, we could do the same thing. The probability they're independent and said not sure would be independent, not sure is 5 out of 540. So for that one, what I would do is do 5 divided by 540, and I would get 0.009, which is less than 0.05. So you could say, yes, this would be unusual since the probability of being independent and not sure is 0.009, which is less than 0.05. And just remember 0.05 is the cutoff for unusual. Okay, so that would be the answer for E. F is if one person is randomly chosen, what is the probability they are a Democrat and said yes? So for probability F, the probability they're Democrat and said yes, that would be 137 out of 540. Okay. Okay, so for part F, we have 137 over 540. So we'll do 137 divided by 540. And I get 0.2537, so roughly 0.254. That would be the answer for F. And then part G would be if a person is randomly chosen, what is the probability they are a Democrat or said yes? So the probability they're a Democrat or yes, that would be the same as the probability they're a Democrat plus the probability they said yes minus the probability they're Democrat and said yes. So if we look at that, the probability Democrat would be 137 out of 540 plus the probability I said yes would be 307 out of 540. But then the probability they're Democrat and said yes would be the one, I'm sorry, the Democrat, I apologize, that would actually be 307. So this should be the 307. That's just being a Democrat. And then the Democrat and said yes, that's the 137 out of 540. So then what I could do is just add all that up, or you could think of it as 307 plus oh God, I screwed up again. Hold on, let's back up again. The Democrat is the row, that's the 200. Apologize for that. So I would then have 200 plus 307 minus 137 all over 540. And that would be roughly, let's calculate it. It would be 200 plus 307 minus 137. So it'd be a total of 370 over 540. And then divided by the 540. And that would be 0.6851, so roughly 0.685. Okay, and again, just to reiterate that, because I did make a mistake, the Democrat would be the whole row, so that's the 200, so that's why that's a 200 out of 540. The yes is the column, which is the 370, and then Democrat and yes is just the 137 where the row and the column intercept. And I kept reading the wrong thing on that one. So that would be G, and then H would be if one person is randomly chosen, what is the probability they're a Democrat or, oh, I just did G. So H, if a person is randomly chosen, what is the probability they are a Democrat? So probably should have asked that beforehand, but the probability of a Democrat would be the 200 over the 540. And that was the one I kept reading incorrectly. I was looking at the column for some reason. So that would be 200 divided by the 540. And that would be 0.3703, so 0.370. Okay, that would be H. And then I would be if a person is randomly chosen, what is the probability they are not sure? So the probability not sure would be that last column, so it'd be 53 over 540. So if we actually go calculate that, we'd get 5.3 divided by 540, and I get 0.09, so roughly 0.098. And then J would be if a person is randomly chosen, what is the probability they are independent or Republican? So probability of independent or Republican, that would be the probability of independent plus the probability of Republican, and then minus the probability that you're both. But you can't be both. So this last part is 0 because they're disjoint. So we would just get independent, which is 110 out of 540, plus Republican, which is 200 out of 540. So we could say that's 110 plus 200, all divided by 540. And that would be roughly, we go calculate it, 110 plus 200. So 310 divided by 540. And I get 0.7574. Okay. That would be J. So then K would be, is it unusual for a respondent to have said yes, why or why not? So the probability that someone said yes is the 307 over 540, which if you calculate that, it's going to be more than 50%. 307 divided by 540, we get 0.569. So what I would say is the probability of yes, which is equal to 0.569, or roughly equal to that, is greater than 0.05. So saying yes is not unusual. Okay, that would be that one. Okay, so I think that's all of number 2. So then number 3 would be, let's scroll down, we'll put it up here. That the probability of E is 0.45 and the probability of F is 0.27 be true, find out all the parts below. So for part A, what is the probability of E and F? If E and F are mutually exclusive. So if they tell us E and F are mutually exclusive, that's the same as what we say is disjoint. And what that means is the probability of E and F is 0. So if we wanted the probability of E and F, it would be that. It would just be a 0 if they're mutually exclusive. They have nothing in common. That would be A. So then B would be, what is the probability of E or F if they're mutually exclusive? Well, if you want the probability of E or F, that's equal to the probability of E plus the probability of F minus the probability of E and F. You want to subtract the overlap. But if they're mutually exclusive, this last part is 0. So then we would just use the information that was given to be 0.45 plus 0.27, and then you just subtract 0. So you really don't have to subtract anything, but it'd be 0.45 plus 0.27. And I would get 0.72. Actually, we can say exactly 0.72. And then part C would be, what is the probability of E and F if E and F are independent? So the probability of E and F equals the probability of E times the probability of F if E and F are independent. And that's on your formula card. So that would be the 0.45 times the 0.27. So if we now do that, and I get 0.1215. Okay. And then D would be, what is the probability of E or F if E and F is 0.15? So the probability of E or F, if there is an overlap, is the probability of E plus the probability of F minus the probability of E and F. And they're telling us in the problem that this last part is 0.15, so that's what we'll be subtracting. So 0.15 will come off at the end, but then it'll be 0.45 plus 0.27. So if we just go through and do the math, and again, all these formulas are on your formula card. So 0.45 minus 0.27, I'm sorry, plus 0.27. Minus 0.15. So I get 0.57. And that would be D. So then E would be, what is the probability of E and F if the probability of E or F is 0.25? So if we do the probability of E or F, that's equal to the probability of E plus the probability of F minus the probability of E minus the probability of E and F. So what they want to know is what the or would be, or what the and would be. So this would be 0.25 equal to 0.45 plus 0.27 minus the probability of E and F. So what I would do is use math and switch sides with those two things. So put the 0.25 on the right, the probability of E and F on the left. And what you'll get is 0.45 plus 0.27 minus 0.25. And that's just a little bit of algebra there. And so if we actually do the math, 0.45 minus 0.27, I'm sorry, plus 0.27. I guess it's just my data. Subtract when I'm supposed to add, and then minus 0.25. So double check, yeah, I typed it in right now. So 0.47. And that would be that one. And then we have one more part. What is the probability of E complement? So F, when you want the probability of E with the little c, that's the same as 1 minus the probability of E. And remember, the probability of E is 0.45, so this will be 1 minus 0.45. And again, you can either do that in your head or you can just use your calculator. And so we get 0.55. And there you go. So that would be question 3. So that one's just trying to use the rules that are on your formula card and get a sense of those. So let's look at number 4. And I think we only have 4 and 5. Yeah. So we have 2 more questions to go, but a bunch of parts. Okay. So among 21 to 25-year-olds, 29% they have driven while under the influence. And this one's actually right from the book. So the probability drove under influence, that is 0.29. So then for part A, what is the probability all 5 have driven while under the influence of alcohol? So the probability 5 drove under influence. And people are independent, so that means it's going to be 0.29 times itself 5 times. Or you could just say 0.29 to the 5th, because people are independent, so you would just multiply that out using the rules of independent probability. So do 0.29 caret 5, and I'm going to get 0.0000205, so roughly 0.002. And then part B, what is the probability all 5 have not driven under the influence? So probability all 5 did not drive under influence. And that would basically be the opposite of 0.29. So if you go through and you do 1 minus 0.29, you get 0.71. So this will be 0.71 to the 5th, because the probability if they drove under the influence is 0.29. So the probability they didn't drive under the influence would be 0.27 or 0.71, or 1 minus 0.29. So what we would do there is 0.71 raised to the 5th, and I would get 0.1804 da 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 da. Okay, that would be B. And then C would be, what is the probability at least one of them has driven under the influence? So the probability at least one of the 5 has driven under influence. So that would include all the crazy combinations of them driving it, or you could say 1 minus the probability none have driven under influence. Okay, well, we already know the answer to that one, because if you look at what we already found, if none have driven under the influence, okay, what would be the opposite of that? So if you look at our 2 previous answers, that would mean all 5. Hold on one second, the dog's crying. Okay, so if you think about it, at least one has driven under the influence for part C. And actually, let's look at part D at the same time. I'm going to leave some room here. So for part D, it says, what is the probability at least one of them has not driven under the influence? So this would be the probability at least one of the 5 has not driven under the influence. So that would be the same as 1 minus the probability none have, well, this is going to be kind of backwards. Probably none have not driven under. So none have not driven under influence. So it's kind of a double negative there. But if you go back up to what we originally had, the probability all 5 have driven under the influence would be this. And then the probability all 5 did not drive under the influence would be this answer. So when we're looking at C and D, if we want the probability at least one of them, at least one of the 5 has driven under the influence, that would be the same as 1 minus none have driven under the influence. And then if we want the probability at least one of the 5 has not driven under the influence, that would be none have not driven under the influence. So it's a lot of double negatives here, but if you think about it, what we would end up doing for that is, what would be the equivalence of none having driven under the influence? Well, if none have driven under the influence, then that means all 5 did what? So if you think about it, it'll be 1 minus, when we do none have driven, this is, we want the opposite of that. I'm trying to think of the best way to explain this. So all 5 did not drive under the influence. Hold on one second. Sorry about that little pause. The dog was whining, so I had to take care of her. Okay, so back to this. So if we want to do the probability at least one has driven under the influence, that would be 1 minus the probability none have driven under the influence. But we just found that answer right here. Let me use my red pen here. This is the probability all 5 did not drive under the influence. So that would mean all 5, none have driven under the influence. So we would do 1 minus 0.71 to the 5th. Okay, we'll get that in a second. But then down here, when it says at least one of the 5 has not driven under the influence, that would be 1 minus none have not driven under the influence, which means that's 1 minus the 0.29 to the 5th, because essentially if none have not driven under the influence, that means that they all did. Okay, so then our 2 answers would be, let me just pull up the calculator here. 1 minus 0.71 raised to the 5th. That will give us the 0.81957 for this one. And if we do 1 minus 0.29 raised to the 5th, we're going to get 0.9979. Okay, so that would be that one. Got a bunch of double negatives there, so it gets a little bit confusing, but that would be that one. And then finally, we'll do number 5 down here. Wait, I'll scroll back up for just a second so you can kind of see. Okay. And then finally, number 5, a standard deck has 52 cards. 26 are red and either a heart or a diamond. 26 are black and either a club or a spade. The hearts, diamonds, and clubs and spades are called suits, and each suit contains 13 cards, the ace, 2, 3, all the way up to the 10, and then jack, queen, and king. And so part A. If one card is randomly selected, what is the probability? It is a heart. So the probability it's a heart. Well, if you look at the setup, there's 13 out of 52 that are hearts because that's one of the 4 suits. So if we do 13 divided by 52, we're going to get 0.25, which makes sense because it is 1/4 of the deck. And then for part B, if one card is randomly selected, what is the probability? Is a king and a heart. So the probability it's a king and a heart. Well, there's 4 kings each from each suit, so there's only going to be 1/52 that's a king and a heart. So if we do 1 divided by 52, I get roughly 0.01923. That would be B. So then C would be, if one card is randomly selected, what is the probability of the king or a heart? So the probability of king or a heart, that would be the probability that it's a king plus the probability that it's a heart minus the probability it's a king and a heart. Going back to our formula. So there's 4 out of 52 that are kings. Hearts, there's 13 out of 52, and then minus the 1 out of 52 because there's only one that overlaps. So we would get 4 plus 13 minus 1. So we get 16 out of 52. Divide that by 52. And we get roughly 0.308 because it's 3076. Okay. So then C, that is C. We'll do D now. So then D would be, if one card is randomly selected, what is the probability the card is not a king? So probably not a king. You could do 1 minus the probability it is a king, because that would be a little bit shorter. So 1 minus 48. I'm sorry, I apologize. Not 48, that's actually our answer. 4 out of 52. So that will give you 48 out of 52. So there's 48 out of 52 cards that are not kings in the whole deck. So do 48 divided by 52, and I get 0.923. Okay, and then we can do E. If one card is randomly selected, what is the probability is a king or a queen? So the probability king or a queen. Normally that would be the probability of a king plus the probability of a queen, and then minus the probability it's a king and a queen. But by designation of how the deck is made up, the king and a queen is a 0. You can't be both. So this would be 4 out of 52 plus 4 out of 52, or your 8 out of 52, which would be roughly, I have no idea. So let's do 8 divided by 52. And I get 0.154 roughly. And then that's E. So then F would be, if one card is randomly selected, what is the probability the card is a king and a jack? So the probability it's a king and a jack. Well, you can't have both. That would be 0 out of 52. So 0. There's no card that's both a king and a jack. Okay. So then G would be, what if one card is randomly selected, what is the probability is a 5 or a red card? So the probability of a 5 or red. So that would be the probability it's a 5 plus the probability it's red minus the probability it's a 5 and it's red. Okay. So there are 4 out of 52 that are red plus 26 out of 4 out of 52 that are 5, 26 out of 52 that are red, and then the 5 in the red would be the 5 that's the heart and the 5 that's the diamond. So there's 2 out of the 52 that are 5s and a red. So that would end up giving you 28 out of 52. which would be, if we did 28 divided by 52, we get 0.538. So roughly 0.538. And then I believe we have one more. H would be, if one card is randomly selected, what is the probability the card is a 5 and a red card? So the probability of 5 and red, well, we kind of used that in the last one. That would be 2 out of 52 because it would be the red heart and the red diamond that's a 5. So if we do 2 divided by 52, we get 0.0384, so roughly 0.038. Okay, and that would be the review. Okay.